Hello guys, in this video we are going to continue with the power rule. We are going to see basic methods of integrals, specifically the power rule with chain rule, okay? And we will see some examples how to apply this power rule. What do we need? Some notions of integration and calculus, and for sure we will need to simplify some expressions. Okay, let's start with the formula. In this case, this formula is something new, it's something known, not new. And let me review the pattern. You need to have a function powered to a number, and outside should be the derivative of the function between parentheses, okay? Remember, the derivative only of the function between parentheses, not the function powered to a number. That is confusing sometimes. If you have this, if you have the derivative of the function inside the parentheses, outside, then the formula tells you that this is the function power n plus 1 divided by n plus 1. Okay? This formula works for any value of n different from -1. Okay? In other video, we saw an application of this formula when the function is just x, and you got it here. The integral of x to the nth power is x power n plus 1 divided by n plus 1, okay? So, in this video, we are going to focus on the first formula, the one with the chain rule, okay? Let's start. Okay, what do you see here? We are going to look for patterns in integrals. 90% of the exercise is to recognize what do you need to do. And this is complicated for sure, okay? In many integrals, you have different ways. You can just choose this method or change of variables or many other ones. Recognize it, at least one, it's very important for you. The problem is that normally we just look at the integral and probably we don't know how to deal with this integral. Okay, let's see if we can understand this formula and apply it as many times as we can. Okay, so what do you see here? I see a function. The function is x squared plus 1. You see here, x squared plus 1. Power square, a square. Okay, so I have a function, a square. The function is x squared plus 1. In the formula would be x squared plus 1. Remember, whatever is inside the parentheses. The question you need to ask yourself is, the derivative of x squared plus 1 is outside. What is the derivative of x squared plus 1? 2 times x. Oh, I got it here. Perfect. I got everything I need to apply the formula. I have a function squared times the derivative. So if you continue with the process, what are we going to write? Is the function between the parentheses power 2 plus 1 divided by 2 plus 1. I add 1 to the exponent and divide by the same number. Okay? And you can ask, okay, but what happened with the 2x here? Nothing. I only need the derivative to be there in order to apply the formula. I'm not going to write the derivative around here. Okay? So be careful with that. Come on, next step. Oh, I'm simplifying here the thing. 2 plus 1 is 3 divided by 3, and that's all what we need. Okay? So, piece of cake. Another example. Another example is that integral. What do you see here? Okay, I see a function powered to 5 and then something else outside. So, my feeling is, a function powered to a number, let's wait. Do I have the derivative of this function outside? Let's see. What is the derivative of x cubed minus 2 times x? Is 3x squared minus 2. Oh, perfect. It's outside. And even the numbers are correct. So I have everything I need. I have a function powered to the 5th power times the derivative of this function. Perfect. What is the solution? So it's the function I was talking about, the one inside the parentheses, powered to the exponent plus 1 divided by the same number. So it's x cubed minus 2 times x to the 6th power divided by 6. Okay? So it's not difficult. The idea is to find the function that is powered to a number, and then outside should be the derivative. If you have this pattern, the integral is solved. Okay? Come on, another example. A little bit more, this one is a little bit more confusing. When you see this, you are thinking, okay, sine, cosine, this is called trigonometric integrals. Should I apply this method here? If you can, do it. If not, you are going to deal with changes of variables, and this is going to be a little bit more complicated. So, how can I apply this method we are applying in this video to this integral specifically? Okay, let's see. I'm going to rewrite this integral as follows. I have sine of x power to 1. Okay, this is obvious. Sine anything power to 1 is exactly the thing I need. So I have a function power to a number. And then the question you need to ask yourself is the following. Is the derivative of this function outside? And the answer is, probably you are all of you are saying yes. The derivative of sine is cosine. So I got a function power to a number, and outside is the derivative of this function. Perfect. So I got everything I need in order to apply the formula. So what is going to be the solution? This function, sine of x, power to the exponent I had plus 1 divided by this number. So let me show you. This sine of x power 1 plus 1 divided by 1 plus 1. Okay, that is sine square of x divided by 2. By the way, writing the square in between sine and x is correct. It's the same as sine of x everything squared. Okay, guys, please remember that cosine should be there in order to apply the formula, but as you can see, the derivative does not appear on the right side. Okay, that is very important. One more example. Sine square of cosine, sine square times cosine of x. This is a more obvious way to apply this formula. Let me rewrite the expression. This is sine of x squared times cosine of x. Same question. I have a function power to a number. The function is sine. And you need to ask yourself, is the derivative of sine outside? Yes, because the derivative of sine is cosine. Perfect. So I got everything I need. I'm going to apply the formula, and the formula tells me that this is the function power, the exponent I had plus 1 divided by this same number. Okay, so this sine cube divided by 3. So piece of cake. I hope you find this easy. Another example. Yes, I'm repeating myself, but I want this to be completely understood. Okay? In this case, it's exactly the same case as before, but with a different exponent. What do we have here? Sine of x. Power to a number. Perfect. Now, the derivative of sine is outside. Yes, the derivative of sine is cosine, that is here multiplying the expression. So perfect. What is the integral then? Sine of x to the 4th power divided by 4 is what I just read, is written there. Okay? More examples. Maybe a little bit more complicated. Logarithm to the 4th power times 1 over x. Everything is prepared just to apply the formula. Look at this. I have a function power to a number. Perfect. The function is logarithm of x, natural logarithm of x. What is the derivative of natural logarithm of x? 1 over x. Oops. Perfect. I got it here. So I got a function power to a number, and outside is the derivative. What is the solution, guys? The function power to the 5th power divided by 5. I just add plus 1, exactly logarithm of x power to the 5th power divided by 5. Okay, so piece of cake. I only need that the derivative of the function inside the parentheses appears there. Okay, one more example. This one is a little bit more confusing. Tangent to the 5th power divided by cosine square of x. Okay, this is a trigonometric integral, and probably if I'm not talking about this rule, you feel a little bit lost, like, oh my god, tangent to the 5th power cosine squared, trigonometric integral for sure, but I don't know how to deal with it. I will have changes of variable, but it's going to take longer. Okay, what happens if I rewrite the expression in the following way? I have a tangent here, power to the 5th power. Okay, do you remember the derivative of the tangent? Maybe it's just only this. And be careful, because we are integrating, we are applying a formula only, and we are reviewing derivatives again and again. So what is the derivative of the tangent? The derivative of the tangent has two expressions, equivalent expressions. One is 1 over cosine square of x. The other one is 1 plus tangent square of x, but this does not appear here. I got the derivative of the tangent here. So I got a function powered to a number and the derivative is outside. So applying the formula, this is tangent to the 6th power divided by 6, and it's done. Something that could be really hard using a different change of variables. In this case, it's just trivial, so piece of cake. Okay. 2 more examples and we are done. In these 2 examples, the only thing that is important is that we miss something, a number specifically. Imagine that you have this, x squared minus 1 to the 5th power times x. A function, power a number, perfect, I have a function, power a number, and outside I should have the derivative of the function inside. But what happened? Sorry, the derivative of the function inside is 2 times x. And I only have x. 1, 2 is missing. A constant is missing. But that is no problem. A missing constant can be solved. Again, I have a function powered to a number, and outside I have almost the derivative. I need a 2 to have the full derivative. So what I'm going to do? I'm going to add the 2 that I miss in the derivative. Yeah, but you cannot add a 2 like as you want. Okay, if I add 2 here, I need to multiply by 1/2 outside of the integral. Okay, this 1/2 will remain. This 2x is going to disappear because it's the derivative of the function inside. But this 1/2 that I just added just to balance the derivative should remain at the end. So what is the solution? Now, if I apply the formula to this part, then this is x squared minus 1 power to the 5th plus 1 divided by 5 plus 1, sorry. 1/2 remains. Do you see here? The constant that I add just to compensate the one I needed will remain on the integral. So let me simplify this. This is 1/2 of x squared minus 1 power to the 6th power divided by 6. If I just multiply, this is 12 on the denominator. Another one, and I'm going to do this one really fast. Function q. The function is 3x to the 4th power plus 2. What is the derivative of 3x to the 4th power plus 2? It's 12x cubed. Oh, but outside I only have x cubed. I don't have 12 times x cubed. It's a constant, what I'm missing, no problem, guys. If it is a constant, I can add the 12 in here, where the derivative should be, and outside I'm going to multiply by 1/12 just to compensate. Remember, this number will remain in the integral, and this one is going to disappear. So, come on, let's see. This is 1/12. The function was powered to 3, so it's going to be powered to 3 plus 1 divided by 3 plus 1. What is that? Okay, if you simplify, this is power to, this is 4, and 4 on the denominator, multiplied by 12, 48. Okay? So, guys, this is the power rule with the chain rule. I hope you understand everything. We just review this type of integrals, and we practice simplifying some mathematical expressions. I hope you find this helpful, and thank you for your attention, guys.